we can begin our discussion. So with that, good afternoon, everyone, and welcome to Renewable Watch's webinar on Overcoming Underperformance Challenges in Wind Turbine Operations, Analyzing Losses and Improving Performance. The webinar is being sponsored by ONYX Insights. I am Khushboo, editor Renewable Watch. And some of the key topics that we aim to discuss during this webinar are wind O&M scenario in India, key issues and challenges, benefits of energy loss analysis, and improving turbine performance, the way forward for this industry. I would request the delegates to keep posting questions or comments in the chat box or Q&A box. We want to make this as interactive as possible. So your questions, insights will be most welcome. We will start with a brief introduction by Mr. Syam Miriala, who is an engineer with the ONYX team. He has broad experience in renewable energy consulting and engineering with an exposure to the new business development and commercial aspects of the industry. He has led and played a major contribution to technical advisory services of wind farms and is presently responsible for customer relationships and creating techno-commercial opportunities to develop and deliver engineering and software innovations in predictive analytics of renewable energy. Mr. Miriala, on to you.
Sorry, thank you, Khushboo. Good evening, one and all. Good evening to the panelists, and good morning to Susie joining from UK. I'll be Sam here. I'll be introducing about ONYX. A quick introduction before I hand over it to Susie for the topic in discussion. Let me share my screen. Hope you could all see the screen. Yep. Thank you. Yeah, ONYX Insight is a global leader in hardware, software, and engineering services of the wind industry. ONYX Insight is an independent company which is into predictive analytics of wind turbines within a strong engineering expertise. ONYX Insight is basically from rotating machinery design industry and helped in the design of gearboxes and all in the past from Romax background. We have had offices in UK, Spain, USA, Korea, India, China, Australia. ONYX Insight is a British Petroleum's launchpad company. Across the globe, these are some of our numbers, like across the globe, 7,000 turbines has been retrofitted with our advanced sensing product called EcoCMS, and then across the globe we are monitoring 14,000 wind turbines for the condition monitoring of the entire drivetrain, and we have had the experience of gearbox teardown inspections and gearbox RCAs, the failure RCAs of all the major drivetrain components. And across the globe, yeah, we have had an experience of 75 gigawatt of data due diligence as part of the performance analysis and all. Across the globe, we've been working with top 6 of the IPPs or the owners out of 10, yeah, that include EDF and Greenco and many other bigger IPPs we are working with. And then when it comes to the product offerings of ONYX Insight, our product offerings has been categorized into 3 different verticals, I can say, which is into software and analytics, advanced sensing, and engineering and consultancy. I'll take one by one, very quick. As part of the advanced analytics, as part of the advanced sensing, our number 1 product is condition monitoring system for the the wind turbine drivetrain, which is an affordable and effective condition monitoring system, which has been which can be retrofitted on the operating wind turbines. This is what I'm talking about. The number of wind turbines has been retrofitted with across the globe. 7,000 turbines has been retrofitted with this EcoCMS. We are offering the complete turnkey solutions where supplying the hardware and installation, commissioning, and providing the monitoring services, and even offering the software as a SaaS service where customers can monitor the condition monitoring by themselves in-house. And across the globe, this is the track record of EcoCMS installations. I can say all the turbine models across the globe has been we have had experience with all the major turbine model, that's Acciona, and then Enercon, and then Gamesa, and GE, and all Nordex, Vestas turbines, Siemens models, and even the ONYX models in India as well. And the second product which we have recently launched under our advanced sensing vertical is EcoCMS Flex. EcoCMS is in a complete retrofit model, whereas EcoCMS Flex is in a CMS upgrading model, which we have launched recently, where the existing hardware can be utilized. That means the existing condition monitoring hardware like sensors and all can be utilized in the EcoCMS Flex. I can show you here what's the difference between EcoCMS and EcoCMS Flex, where in EcoCMS we can't use the existing sensors installed on the turbines. Whereas in EcoCMS Flex, we can utilize the existing sensors on the turbine. That may be of SMP systems of Gamesa or BKV systems of Vestas. All these can be utilized. The existing sensors can be utilized, and only replacing the data logger. By replacing the data logger, you can pull the data from the with the existing sensors, and the same data can be processed for monitoring. This is the new launch of EcoCMS Flex across the globe, where it's in a not in a complete retrofit, but it's in a it's an upgrading to the existing hardware, which we are offering, started offering in India as well. And then third product in advanced sensing is Echo Pitch, where to monitor the health of the pitch bearings of the wind turbine of different failure modes for the raceway deflections, and then macro pitting, and then axial cracking of the raceways, and then separation of the blade from the bearing. This is one of the failure mode which we extensively using our product Echo Pitch. These are all the advanced which we are offering under advanced sensing vertical, where means we have not limited our offerings to the drivetrain system alone. With the Echo Pitch and with the advanced sensors usage, we have shifted our predictive maintenance to the entire drivetrain and entire turbine model. That's to rotor imbalance and oil sensing and generator advanced analytics and tower frequency also covered as part of our advanced sensing products which we are offering. And when it comes to the software and analytics, the product which we are offering is the fleet monitor, which is a powerful analytic tool for the vibration data monitoring or vibration data analysis. The major advantage of this software platform is hardware agnostic software, where it can also take the data from other hardware, also can be integrated to the software, and which can be analyzed and monitored. Not only the vibration data, even the oil quality, oil sensor data can also be integrated with the same platform to analyze the oil quality and the particle counts in the oil, and then temperature data, and then inspection reports also can be analyzed through this software called Fleet Monitor. Across the globe, we are monitoring the 14,000 turbines through Fleet Monitor, in which 7,000 over 7,000 turbines are fitted with the EcoCMS, ONYX Insight hardware. Remaining turbines are being monitored from the independent hardware, where GE Bentley Nevada hardware, Gamesa SMP hardware, and Siemens Gamesa Gram and Joule hardware. All these hardware data also can be monitored to the software platform Fleet Monitor. Here also the track record of the Fleet Monitor you can see. And the all-class monitoring services which we are offering through the Fleet Monitor, where means lead time of the major components, identifying the failures in the major components, which is having a lead time of more than 6 to 24 months for all the slow speed components, and then for 1 to 6 months for all the high speed components. And the second offering in the software and analytics part is ONYX A-Hub, where the platform for the entire fleet managing for the wind farms, for the owners where they're having many wind farms under their portfolio, where under the A-Hub tool or the software, we can integrate. We can pull the data can be centralized, the data from different streams, that may be of vibration data, that may be of oil analysis data, inspections data, scatter data, all the data streams, the blade inspections data, all the data streams can be pulled to one platform, that is A-Hub platform, which can be analyzed, and O&M decisions can be taken based on the analysis of the data. This is one of the platform where our underperformance vertical also under this, which my colleague will take forward. And under the advanced analytics, there's one more tool called Field Pro, where we can analyze the which can be utilized for the inspections of the in the operation and maintenance phase. That can be of end of warranty inspection, that can be scheduled maintenance inspections. All of these can be managed and maintained, tracked through the Field Pro software. And the third and the final vertical of our business is engineering and consulting. With the experience of rotating machinery background, and majority of the ONYX Insight engineers are of wind turbine background, we are offering engineering and consultancy and all sorts of in the complete life cycle of the wind farms or the wind turbines. That can be the root cause analysis, or O&M forecasting, O&M cost forecasting, and then life analysis or the life extension analysis, and the drivetrain inspections, and the gearbox re-engineering services. We're offering all of these services under our engineering and consulting service. Yeah, that's all from me. Handing over to Khushboo. If you have any questions, I'm here to answer.
Thank you, Mr. Syam. I'll quickly move to Dr. Susie now. Dr. Susie has a short presentation for us. She's team leader machine learning at ONYX. She's a data scientist with expertise in analysis of time series data. At ONYX Insight, she's working on developing algorithms and software to improve wind farm production and reliability. She's also a lead instructor at Code First Girls teaching coding courses for women who want to move into technology job roles. She's fluent in multiple coding languages. She received the George Green Prize for Mathematical Physics First Class. She has a PhD in Civil Engineering and also holds the APM Project Management qualification. Dr. Susie, we are ready for your presentation. Mrs. Syam and Dr. Susie, whatever questions that come up, we'll be happy to take them during the panel discussion since you both will be there. So we can move to the presentation and then the discussion, and then we can have a joint Q&A across everything that's discussed. Dr. Susie, we can start with your presentation.
Okay, perfect. Thank you very much. And thank you for my introduction. Let me just share my screen. Okay, hopefully you can see that well. So I hope you're all doing well today and you're not too tired after the cricket. My husband and I also watched it, but maybe at a less late time than you on the call. Yeah, fantastic end to the game. So today I'm going to talk to you a bit about analysing losses and improving performance. So let's kick off. So what I'm going to talk to you today is a little bit on what kind of performance challenges we see, and then a little bit on how can you address those challenges and the type of analytics you can do in order to overcome that. So I love to speak about analytics, I love to speak about data. Today I'm mostly going to speak about SCADA data, which is the data that comes off the wind turbine control system. But as we already mentioned at ONYX, we do a bunch of other analytics outside of this topic too. So yeah, what challenges do we see to kick it off? So first I'm going to talk about what energy losses are and why they occur. So in the first case, you might see performance losses because sensors or controls on the system are not working properly. So for example, you may have an anemometer that becomes miscalibrated, which means your wind turbine is shutting down when it shouldn't be. So for example, if the sensor is reading higher than true, it might shut down in the high wind period, which would lose you quite a lot of production because that's when you really want your well, when the turbine should really be operating at its maximum. You might also have cases where there are health issues on components in your turbine. So for example, you may have a main bearing issue, and because of that, you make a decision to derate the turbine. So you reduce the maximum power that it can produce while that component is in damaged state. And yeah, that could be losing you quite a lot of production. And in some cases, we've even seen the amount of time it's been derated and the cost of that is kind of so expensive compared to the price of the component in the first place. So you have to be quite careful you don't end up with this kind of indefinite derating. Okay, so something else that might be causing extra energy losses if you have a downtime because you have some failure, specifically if you don't know that failure is going to happen, so you don't have time to plan for it and to get the parts in, so you might have a longer period of downtime to make that replacement or that fix. Because you didn't know it was going to happen, so you couldn't be ready, which is why kind of monitoring your components on your turbine in advance can save you money in the long term. You might have cases where you've really aggressively derated a turbine. Maybe you don't need to derate that much, so reduce the power that much at the start. Maybe you can do more of like a gradual level of derating and overall optimize how much you produce. You might also have wind sector management that's very aggressive. So the OEM might have said these turbines need to be derated at certain wind directions, but actually that's quite yeah, an aggressive strategy. Maybe that could be reduced. So when we look at these kind of analyses, sometimes we will find energy that can be recovered by making changes, and in some cases it's inevitable. So if you need to derate a component, then you need to derate a component. You're never going to get that back. Okay. So what components are causing underperformance? This is taken from a study we did with a large onshore operator. They found that blades, pitch systems, and electrical systems were kind of the top causes, and this is something we see across multiple customers. In fourth place, we have gearbox. This one we can monitor with vibration, so sticking the accelerometer sensors on the drivetrain and looking at you know, how long till these components are going to fail. But there's a bunch of other things we can look at using SCADA data, which is the data that comes off the turbine controller. And this data is really quite cool because it's largely in the turbine already. So as long as you can get access, you don't need to instrument the turbine further. You can use that data to do analytics and draw some conclusions. Okay. So why do we need it? Can we add this analytics in? And why is it important? So firstly, if you add SCADA data in with vibration monitoring data, you can look at the condition of more components, which is good, more visibility of what's going on your turbine. Secondly, in some cases, you might have two trends, one vibration and one SCADA. You could monitor with both. I'm going to talk about this a bit more later, but you'll see slightly different patterns in the two trends, and you can use those to make a more informed decision on what might be happening up the component, especially if it's one of the major ones. You might find that there are some issues with the control system. They might not be easily visible, so the turbine will generate different alerts. And if you're just looking at these and all the raw data trends, it's very hard to pick out exactly what's happening. So it helps a lot to use more advanced techniques, a little bit of machine learning or statistics, and try and combine all these data sources together and get a better idea of what's going on without having to manually click through or make loads of Excel plots or do it as efficient as possible. And then finally, you can look at all the issues you found across your farm and look at how much is that costing me in real term money as an estimate, or how much might that cost me in future in order to kind of prioritize. So which ones should I really address now versus what could I leave and wait? If I've got a number of pressing issues, which one should I do first? So it kind of enables this kind of analysis too. So I'm going to talk very briefly on how to analyze these losses and then what actions you can take. Wrap up with a little bit about what we do at ONYX. We can definitely go into more details of this with questions afterwards too, if you like. So there's a number of steps, in my opinion, to figure out what's going wrong and then how could you recover it. So the first thing that I believe you need to do is you need to figure out how is the performance on your farm. And I've seen people clicking through tools, looking at power curves by eye. It takes a very long time. It's quite repetitive. So ideally, you want to do that in an automated way that gives you time to focus on the really important issues. So that's the first step. The second step is to look at the data that you've got, find out if you have any issues in the sensors, because when we come on to step 3, which I'll mention in a bit, if the data in your sensors is not good or it's not reading quite right, you're not going to get good models coming out. So you need to understand, what is the sensor telling me? Is there any issue on the turbine? And then step 3, can we use that knowledge that we've gained from the performance and the sensors to get an idea of what reliability issues there are on the site? And then what actions do we take? So how do we schedule work? How do we reduce downtime? How on the whole do we improve the performance of the site? And then, as I kind of mentioned, the overall kind of theme of this is, how do we prioritize? Can we assign a value to these so you can get an idea of how much might you actually lose, and then you can accordingly. Okay, so I'll briefly talk through each of these steps. First, I'll speak a bit on step 1. So how can you automate performance analysis? So on the left, you can see a power curve. The kind of axis along the bottom, this is the wind speed, and coming up is the power. So you can see there's kind of this curve where most of the points fit, which is in kind of a yellow line for the site and in a purple line for this particular turbine. And you can see kind of a distribution on the bottom of where the wind is. So mostly the wind is around 8 meters per second, and the power coming up in another chart. And you can see it goes up to 2,400 kilowatts, but there's a big bar at 1,000 kilowatts, which is a derating on this turbine. So what you can do, you can use some analytics, which are a combination in this case of engineering understanding and machine learning, to classify exactly what's going on. So how much did the derating cost me? That big blue line around 1,000 kilowatts. How much was the downtime, which are the red points you can see along the bottom? And is there any shift in the power curves over time? So what we try to do in ONYX, I love to use engineering understanding. So I know that when the turbine is derated, the pitch angles are not typical because you've kind of pitched out of the wind sooner. So how can we make use of that information in order to make these classifications, so I can put the data for the power curve through an automated algorithm, and it can say, this is how much was derated, this is how much was down, this is your curve, this is the normal points. So this is the first part. And we can take this one step further. So on this site, there was a lot of issues with icing. So you can add extra things here. So in the graph at the bottom, we've got points that were classified as icing over time. And that's including the weather data and looking at if you have detected any extra inefficiencies due to changes in CP lambda curve. And again, you can automate that whole analysis so that you don't need to look at it yourself. You can get the answers out. So that kind of wraps up step one. The second thing we can do is look at the sensors and the data, build on top of the performance analysis we did, and look for losses. So this is just one specific case, but one we see a lot. So I thought I'd talk through it. On the left, we have power curves from across the site, and you can see there's a few that are a bit below, the others look a little bit abnormal. Then the next thing to look at is that actually an underperformance, or is it the sensor? So we have an analysis in the middle. This is the results, and what we're looking at is kind of red means that the sensor is reading higher than expected, and blue means that the sensor is reading lower than expected. So we've used a method to get what we predict it should be versus what it actually is, and then we can identify. So in these cases, the red bars are 2 turbines where the anemometer is miscalibrated. And then the third thing, we can bring in the data of what events were triggered on the turbine, what were those labeled as, what did the control system say. Combine that with our automatically detected derated points, and we can say how much energy did we lose for each of the different events that happened on the turbine. And in this case, you can see the same turbine that has the miscalibrated anemometer is having a lot of high wind shutdowns, a lot more than the rest of the turbines on the site. And this site was quite flat, so we know it's not just because it's more windy. So by combining all these different data and analyses together, we can get a good conclusion that there's some issue with the anemometer, and this was really expensive. So $20,000 per year was costing the site. And it's a small fix. It's something that quite easily goes unnoticed. Okay, so my final step, we want to look more proactively. So how can we plan for the future in order to minimize downtime rather than just fighting fires and saying, we've already got the downtime, what should we do? What could we do in 12 months' time? What decisions will we need to make in the future? So I've just pulled a small example. This is a main bearing. So you can see in blue, this is the vibration trend. So if you put an eco CMS or another CMS system to monitor the vibration on this bearing, you can get these kind of trends out. You start to see the trend a bit earlier in vibration, which is a real benefit. And then a little bit later in black, this is a SCADA temperature model trend. So we use some machine learning model similar to what I mentioned before and look at how's the temperature different from what we expect. And you can see the temperature starts to come up when the fault is really quite bad. So you could say in your kind of plan, if the vibration is a bit bad, we'll track it. Once the temperature starts to go up, we know it's really bad, we need to take an action. And then after you replace both, so you can see they kind of both reach a peak, both metrics return back to normal. So this is kind of the part I mentioned earlier about we can combine these trends if we have for both and get more information about what might be happening on each individual component. So just for a bit of context, I did a bit of calculations based on kind of a 3 megawatt turbine, 0.5 capacity. You get about $1,500 per day cost in downtime. So say you were to kind of half your downtime by knowing what was going to happen a bit more in advance, that's pretty worth the investment. Okay, so what do I think is kind of essential to maximize the recovery of your energy? Bit of a recap. So first, combine multiple data sources, try and really understand what's going on. And then you'll be able to kind of inform your own decision making. As I said, focus on the important parts, not kind of the boring bits that can be automated. If you're going to do a method such as a machine learning or AI method, I personally believe that using all the engineering knowledge you have to inform those methods gives you a better result in the end. And then finally, it's really beneficial if you can enable your decision making by knowing how much different issues might cost you. So just a kind of small plug, how can we help you with that? We have some analytics that do a lot of these topics. So we cover a lot of reliability issues, so drivetrain temperature, oil system, cooling system, if there's nacelle ventilation or pitch hydraulic systems. These are all different machine learning or statistical models that can be tailored towards the site that we look at, depending on the site geography or what SCADA data is available. And then we have a bunch of analytics looking at performance and how much energy losses there might be. So looking at power curves, yaw misalignment, pitch calibration, downtime, derating, which I mentioned already, inefficiencies, sensors, or wind sector management. We go for physics-based models combined with big data and using some AI and ML approaches. My final slide, what does this look like for us? This is kind of our standard way we work with customers. So we would have a good planning call, look at if there's any deep dive analytics, so things outside of the standard offering that are specific to your site that you might want us to add in. Work together to curate the data and share it, make sure the data quality is high, just any improvements needed there. We then do our own ML model and analysis. Each model is tailored to the site, informed by how the site is set up, how many turbines, how old they are, etc. Followed by an engineering review by one of our team, and then a deep dive call to really explain the results and discuss further. So with that, I think I will pause and pass back. We can move to the panel, and yeah, do please ask any questions. Thank you for having me today.
Thank you so much, Dr. Susie. I do see a lot of questions already being put up in the Q&A box. So that means the presentation was really interesting for all the delegates who are present here. What we can do is I can move to the panel discussion, and then we can take up these questions one by one during the discussion. I hope that works with you. All right, great. On that note, we will begin with the panel discussion, and I will introduce the speakers one by one. Dr. Susie is definitely going to be there in the panel, and I've already introduced her. I'll move to the other speakers now. Mr. Kumud Niranjan Mishra, who is General Manager Wind Operations at Hero Future Energies. He has over 14 years of experience in the energy sector. He is heading wind operations of the company, having a total asset base of 583 megawatt of wind assets. He's also looking after asset performance optimization and innovation in wind farm optimization. In the past, he's worked with Skiron Renewables, Adani, and Sterlite. He's an electrical, electronics, and power engineer. He's also a certified chartered engineer. I'll move to good afternoon, Mr. Mishra. I'll move to Mr. Subhakanta Nayak now, who is Group Head Wind O&M at Tata Power Renewable Energy Limited. He has over 16 years of experience in wind O&M, project and asset management, and he's an electrical engineer by training. A very warm welcome to you, Mr. Nayak. Moving to Mr. Umesh Raichandani now. He's Senior Manager Operations at EDF Renewables India. He has experience in wind, solar, and hydro energy sectors. Currently, he's looking after performance analysis and heading the Operational and Control Center. He's an electrical and electronics engineer by training. Last but not the least, Mr. Niraj Shah, Head Operations and Maintenance Wind at Apraava Energy. He is heading the asset management for wind assets for the wind fleet, 1031 megawatt of operational and 145 megawatt, which is under commissioning. He has 28 years of experience in wind and solar farms engineering, grid integration, compliance, designing for renewable energy farms, industrial automation applications, operations and maintenance management, strategizing the maintenance practices, due diligence for inorganic growth, developing self and teams. He is an electrical engineer by training. Great. We have a very good lineup of panelists here, and we hope to have a great panel discussion now. So we have about roughly 55 to 57 minutes for this discussion. And what we can do is that we can start with the panelists one by one, starting with Mr. Mishra. Mr. Mishra, we can start with you telling us about the total wind asset portfolio that Hero Future Energies has. And what are some of the top 2 O&M challenges that you currently face in these assets? We can just limit the challenges to 2 maybe per person so that we can cover all the panelists and keep the discussions interactive. Yes, starting with Mr. Mishra.
Thanks, Khushboo. Good afternoon, everyone. Good afternoon, panelists. So we have, I belong to Hero Future Energies. We have total asset base of around 1.6 gigawatt, in which 583 megawatt is of wind. This 583 megawatt is a mix of Siemens Gamesa, Suzlon, Inox, and Regen turbines. Coming back to main challenges which we face, like all other IPPs which are less than or around 1 gigawatt in wind, we also face challenges in data availability from OEMs, because data is gold in the current scenario. And we had very detailed brief from Miss Susie and Mr. Shah on how we can use data for analyzing our assets and improving the performance analysis. So at the moment, data availability is a key challenge, plus calibration of the equipments like sensors, the wind anemometers and all. The industry has not matured to that level so that we gaze even minutest fault into all these sensors. However, we are analyzing all the performance based on these sensors, but calibration is not there. In fact, the SCADA system which is available from the OEMs, they are not that interactive, so that they can identify even minor differences between the sensors and give us a pop-up on the errors or warnings, which can help us in calibrating these equipments. So we keep on investing our resources, we keep on investing our time and money on correcting the fault, which is not even there. The sensor is faulty, but we assume that machine is faulty. So that is one of the challenge which we are facing. Apart from this, there are balance of plant challenges, like there are issues with documentations, issues with 33 kV lines which are constructed at the project site, which kills much of the generation apart from these performance initiatives in wind assets at the moment. Thank you.
All right.
We'll join later. Yes.
Thank you, Mr. Mishra. Mr. Nayak, we can't see you, but yeah. Mr. Nayak, again, the same question for you, your portfolio that you're handling, and also top 2 challenges. If they're the same as what Mr. Mishra said, then you can say the same, or if you want to add something new, then you can add something new as well.
Good afternoon. Thanks, Ms. Goyal, for inviting me, and thanks other panelists also for joining. Actually, I'm heading Group Head as in Gujarat. I'm belongs to TPRELs, TATA Power Renewable Energy Limited. We have thousands plus megawatt operating assets of winds. Actually, we have major challenges in wind operations we are facing related to the OEM not performing as per the requirements, and the technical issues related to the technical failure of the gearbox generators is lagging to us for reaching our business target, and dependency of spare for again for the IPP means is dependency of spare to the Western country means we are the lead times to arrange the spare is quite high. So this is one of the challenge, and improper asset management and by OEM means not focus on the pure performance parameters. Incompetency of manpower also means in 2006 to 2010 it was quite good of having competent manpower, but post 2006 to now onwards the turbine capacity is increasing rapidly, but in that ratio we don't have competent manpower in India. I can say we are not developing this talent because everybody is going in pressure situations. So we are directly hiring the peoples from industry. We are not developing the young perform in wind turbines. So that was the major challenges in my point of view.
Thank you, Mr. Nayak. I'll move to Mr. Raichandani now. Your thoughts.
So thank you so much, Renewable Watch. And yes, so as a portfolio, we have currently a 605 megawatt in operation, and by next 1.5 years, we'll get doubled. Some projects are in pipeline. So as a challenge point of view, I have seen a very good presentation from ONYX Insight. And the major thing is that no EM is open to accept the changes. Like if we got some means outcome from the SCADA data or from the condition monitoring system. So what we have seen in India that no OEM is accept your outcomes to install in their turbines, to implement in their turbines. Like just take the example of one of the study of yaw misalignment. And if you got the offset, so they are not ready to implement that offset in their turbine. So that's the one challenge that the OEMs is not so open in India. Okay, so they more rely on their design aspects, and they don't accept your outcomes on that. One thing is that, and second is the condition of OEMs is not so good in India. So there is a scarcity of spares. They don't maintain your assets properly because they don't do the maintenance as per their timelines. So the thing is like that. If you can't maintain your assets in if there is a guidelines to maintain the gearbox oil and to change the gearbox oil or filter the gearbox oil in a year, or to change the gearbox oil in a 4 year or 3 years, so they can't do, because they have a crisis of their financial crisis as well as their scarcity of manpower, resources, and all. So the main thing is that the main challenge is with OEMs, like the resources and the maintenance. And definitely it's very good suggestion from ONYX that if we go for the predictive maintenance, so definitely the plant will perform well. Okay, so that's the one thing. And I think for as a IPP, the main focus is to optimize a plant as much as possible. So that's the thing. Thank you so much.
Thank you. So a lot of challenges related to OEM, according to the panel. Mr. Shah, what are your thoughts?
Yes, so I'll not take more time on the OEM. That's one of my favorite topics. But I think one of the factor which is coming up is the electronic obsolescence, because that is something which we will come across for most of the products which were developed 10 or 15 years ago. And I think Umesh did touch about it, or Mr. Subhakanta touched about it, is the suboptimal manpower. So everybody is consuming the manpower from the OEMs, and the OEMs have now stopped developing their manpower further. They are not training. So the industry as a whole, which was surviving on the pool which was generated by the OEMs, we are facing serious problems because of that now.
All right. Thank you. And Mr. Shah, what portfolio does Apraava?
Oh, sorry. We have a portfolio which is comprising of 4 OEMs primarily. The Enercon machines from WWIL. We have machines from Suzlon. We have machines from Gamesa and Vestas.
Right. Okay. So Mr. Miriala and Dr. Susie, we heard OEM related challenges, data, spares, lack of trained manpower. I think these are the data sharing, obviously faulty sensors also, I think someone mentioned. So what is your overall take on the wind O&M scenario in India? Any one of you would like to, Mr. Miriala or Dr. Susie, anything that you would like to add to this? Dr. Susie, would you like to?
Yeah,
I
can go. Yeah. So everything that you've mentioned was something that I already had on my list and something that we've heard from many people. So being able to access data to understand what you have, having supply chain issues or long lead times for spare parts, and managing the relationship between an operator and an OEM, all those things and the other issues mentioned today, we hear again and again at ONYX.
Right. We move to the second part of the discussion, which is on the key reasons for wind turbine underperformance. I'll start with Mr. Shah now. What are the major reasons for this turbine underperformance? I think you briefly mentioned, or you, not you, but someone else mentioned that gearboxes failure and all of those things. So what is the key reason for underperformance in India?
I think there are 2 major issues, to be very honest. One of them is the intangible part, which is that when we make the business assumption, when we say underperformance means actually it is underperformance against our business estimates. And generally the wind resource, normally I think all my panelists can echo what I'm saying, is that the wind estimates always had been on a higher side, and wind year on year has been declining. Now, the machine availability all across in anybody's fleet, I would be very sure that unless there is something untoward which is happening, unique happening at a site, more or less everybody has 96% machine availability. Am I right, my colleagues? All the panelists, right? Now, if I have 96% availability, if I say I have zero breakdown, that means I can go to 98% availability because 2% I need for my preventive maintenances and inspections anyway. Now, my shortfall in the wind is 10 to 20%. The maximum I can overperform is 2%. So there is a gap in terms of the commercial underperformance, which is always there for all of them. All the IPPs are facing that challenge. This is number one. Number two, the biggest problem what we see is the kind of manpower which is there. They don't have enough materials available with them when they move into the outage. So either you have to take multiple outages or the work is half done and the turbine is again put into service. One of the major factor for this reason, which I was just taking from the presentation of Dr. Susie as well, being an instrumentation engineer all across, is that most of the turbines in India are designed with the concept of the lowest capital cost. And the cheapest way to build a turbine is that you build a prototype with so many instruments, check that everything is stable, and then remove those instruments and slightly remove the automation. This is how it happens. So once you have a stable design which is proven, then you go ahead with the minimal sensor. Now, one of the problem is that unless you can see, you cannot control or you cannot predict. Dr. Susie can correct me. If you have sensors which can interpret the physical information of how the turbine is behaving, then possibly you can decide whether it is doing something right or wrong. In most of the cases, people with minimal sensors are actually blinded. If you go to any gas turbines or steam turbine, for most of the critical sensors, you will always have at least two sensors. One is the main, another is standby. You keep comparing the two. If there is a problem, you stop the machine. Here, even on the nasal vibration, actually, I have only one sensor. So when there is a sensor alarm and the machine shuts down, you know what the operation guy does? He starts up the machine again to confirm whether the alarm is genuine or not. So these are simple, funny things. But this is where, because people do not have so much of information on their SCADA before they go into the outage, they cannot plan the material well. And hence, the preventive maintenances are suboptimal at one level. Next year he goes, he corrects the previous defects, but then there is something new which happens. So that is something which is a cascading effect, which can subsequently lead into a critical failure. And when critical failure happens, Khushboo, what happens is that I think the panelists would have had similar experience, is that at that time, OEMs and the investors, we all don't want to make headlines. So the root cause analysis doesn't actually happen that deeply from the OEM side as well as from the sub manufacturers of the OEM. They rather take any failure as just one failure, replace it and move on. This is something as an attitude which has crept into the industry, and the ecosystem of the industry has actually accepted this behavior, which is, in my view, this is a problem, honestly.
Right. I'll move to Mr. Raichandani now. Your thoughts on the same question, major reasons for turbine underperformance in India.
So I am in line with Mr. Shah regarding this ME issues. Definitely all OEMs have their benchmark of 96%, and they never think about means if we go above that, because that's our call. As a IPP, we always need to have a more and more machine availability. Okay, because OEMs don't bother about that, because below that they have a penalty clause. Above that they always got the bonus. Okay, so that's the one thing. So the one means let us say overcome of this machine availabilities to transit this to EBA, energy-based availability. So in EBA, we can get a more and more insights of the losses and all. One thing is that, and second is definitely the challenges. Like if we just talk about the challenges of this underperformance of these turbines. So I'm in line with Mr. Mishra. He has talked about the availability of data. Availability of data is important, but the second aspect that your data must be accurate as much as possible. Okay, because we have seen a lot of in lot of cases that your wind speed is manipulated by lot of other factors of this compensation factor like NTF correction and all. If your wind measurement is not correct, so you never know, means your turbine is underperforming or overperforming, because the main thing of your performance analysis based on the power curve. Okay, so for power curve analysis, definitely the wind is a very wind plays a very important role. What we have seen in most of the cases, and the last one is that the negligence of means by OEM on the warnings. Means in turbine there are a lot of warnings, but they always make a negligence on that part, and they avoid that to attend these warnings. If we act on the warnings, so we can save a major components to fail in future. So these are the main aspects from my side. Thank you.
I'll move to Mr. Nayak now. Mr. Nayak, your thoughts on the topic?
Yes, actually, the main cause of underperformance is, as I said, we don't have competency manpower. Then it is first is poor workmanship. Actually, the trouble can be sensed by the engineer. Whenever I was that this turbine is not running in the proper power curve. I can sense by showing the speed of the turbines. So nowadays, the competency is the major things. And second things is the major component failure, as I said, the gearbox is failure, the generator is failure. And sometimes I feel that for Indian environmental conditions, the turbines is having a lot of temperature error, is facing temperature error. Like we have a lot of potentials, wind sites in Jaisalmer and Bhuj sites. But in summer, even in high wind seasons, we can see this turbine is running smoothly whenever the temperature is less. But the turbine is having issues whenever the temperature is rising. Suddenly, the temperature is going to 50 degrees. Then it is very difficult to achieve the performance. Automatically, degradation is happening in terms of performance. That is the major challenges in my point of view.
Right. Mr. Mishra, your thoughts?
So I agree with what Mr. Niraj, Mr. Nayak, and Mr. Raichandani have said till now. And one addition to what they have said is the blade underperformance. So blade is one of the most important component as far as thrust generation on the turbine is concerned, and power generation of the turbine is concerned. But my friends would agree that blade is the most ignored part in the maintenance of the turbine. The OEMs as well as the IPPs, we guys are not focusing on timely blade cleaning or its pitch alignment, or say if the blades are having vortex generator, whether it has come down or not, and the leading edges are eroded or not eroded. So if we maintain blades properly, even at a 2-year basis, I believe we can improve the performance by say 0.5 to 1%. In addition to that, what Mr. Nayak said, that temperature related issues are there in the turbines. See, all these turbines are designed mostly by the European players. So they have not understood that in India, the ambient temperature in the state of Rajasthan and even in part of MP goes beyond 48-50 degree. So in that temperature condition, the machines definitely get into either auto curtailment or by failure of components, you get manual stops. So it is also a major reason. And in fact, we have this particular May month wherein the temperatures are very high, plus we also get high wind. So high wind and temperature both combined together definitely puts these machines under tremendous stress. Third point, which I believe, which was also covered by Mr. Raichandani, was related to OEMs. See, these OEMs, if you talk about 8 years back, they had very good profit center from these machines. So they were putting in good components. But now what has happened with the kind of inventory they have, they are putting in the repaired components in the machines. And at IPP level, I believe we don't have that much team available at site who can keep a check on each and every component which are getting replaced in the turbines. So if the OEMs are putting in a repaired component in the turbine, definitely it will give you underperformance maybe 3 months down the time, or 6 months, or say 1 year. So these three are for me the most important elements which needs improvement as far as improvement in the turbine performance is concerned.
Right. Dr. Susie, I'll move to you. So now that you've heard all the challenges and everything, what kind of solutions would you like to propose to these IPPs who are here?
Okay, nice. Yes, I had a couple of points. So Mr. Shah made a really fantastic point about instrumentation on turbines is not good. So you may only have one sensor, and then you may not even have access to that sensor. So what we do a lot, ONYX, is to keep building out new advanced sensing things. So we find a problem in the turbine, and then we think, how can we make it easy for an operator to instrument that and to have access to the data? So we have been working a lot on monitoring pitch systems, and now also starting to move, what can we do more around the blade? So trying to keep identifying that, and obviously if you go with an independent person who's not the OEM, you can have access to that data, which hopefully is beneficial too. The other piece that I thought was really interesting was about when there's an individual failure, it's quite easy to chalk it up as it's a one-off. But something that I really enjoy about working at ONYX is we see multiple different farms all across the globe with similar turbine makes and models. So we can start to see patterns like this one-off thing that happened here. It wasn't actually a one-off. It might be a significant enough percentage of turbines to make more of a case. So yeah, my 2 cents to add in that one.
Right. Mr. Miriala, would you like to add anything to that?
Yeah, I'll agree with the panelists, like whatever the Kumud mentioned. One of the reason for the underperformance is the blade erosions, and then blade is not being taken care, or the predictive maintenance has not been given that much of importance for the blades and all. And even one of the points Subhakanta mentioned, like during the summer season, where when temperatures rise up, ambient temperatures, and then automatically the underperformance of the components. I mean, that may needs to be checked. Once we get an access to the data, then we can see that is it really the temperature causing the underperformance, or is in a default setting of an OEM which is causing the underperformance. If we can get an access to the data, for sure we will be in a position to given a better analysis of that. As Susie also mentioned few points, like the wake effects, and all of these are which were defaults settings by the OEMs. When we get into when we get the data, and when our team analyzes and then compare the turbines with the similar platform turbines across the globe, where we are having the access to the database, where we can compare, and we can get back, and we can help out the IPPs in India for the real root causes of it.
Right. I'll move to Mr. Nayak now. Mr. Nayak, so speaking about analytics and digital technologies, predictive maintenance. So what has been your company's or your experience in this predictive maintenance space, or energy analytics space, and how do you feel these technologies, how can they help in improving turbine performance?
Yeah, we installed conditional monitoring device so that it can be sense the vibrations, and we can so that the proper action plan could be taken. And we also developed a performance department to develop for power curve verifications for each single turbines. So we are doing that. We also solved a lot of issues, but still, because of this uncertainty of this temperature parameter, suddenly, because few weeks before the turbine is running fine, and if the temperature is high, then suddenly the performance is going degrading. So it was really challenging us, but so that's we recommending this cooling factor need to check thoroughly, and we are doing proactive work before the high winds, and we developed a team, dedicated teams to check all the checkpoints. So that's only our action plans to um, address these issues.
Right. Mr. Mishra, what experience have you or your company had with, analytical tools, with with predictive maintenance, with these advanced analysis systems?
See, at the moment, it's more of reactive maintenance in our company, but we are slowly and steadily moving towards predictive maintenance because the entire industry is moving towards that. And I believe none of the companies can say that they are totally into predictive maintenance as of now, because people are dependent upon the external technologies as well as they are dependent upon the OEMs if they have OEMs on ground to do the things. So
Right.
coming back to predictive things, so we have a central monitoring station designed by BACS. So that system gives us proactive alerts. It gives us analysis wherein we can take timely actions. Plus, we have also partnered with ONYX Insight, and we are doing a POC at two of our sites to check how effectively we can run these proactive things at site. So these are the two major things which we have done till now on the proactive and predictive analysis.
Right. Mr. Raichandani, your experience with analytical tools, with advanced analysis, with predictive maintenance, all of these things that we've been discussing.
Yes. So as a digital operations of this EDF Renewables in India, so we have a operational control center which runs 24/7, 365 days with 3 shifts. Okay, so the first step is to monitor the assets effectively for the wind speed, active power, alarms, warnings, curtailments, and also a part of regulations like DSM and all. And the second step means the outcomes come from the monitoring from the operational control center. There is a first level of analysis based on the SCADA data, like power curve analysis, alarm and warning analysis, and also there are a lot of other analysis which gives us a deeper idea about the turbines. And we have an arm of this performance analysis and enhancement, which is also part of asset operations. So the analysis which comes from the as a first level analysis from operational control center, it's now passed on to performance analysis and enhancement department, and they further deep dive their analysis, and the results will share with OEMs for further implementation in turbines. So definitely, we are using like a predictive maintenance, proactive maintenance tools from our day-to-day operations, and digital operations of comes from these domain is really important for overall improvement in performance of the assets.
Right. Mr. Shah, again, the same question for you. Your experience in the predictive maintenance space.
So honestly, we have an AI ML based platform. We have been using it for last 2 years. The interesting part which happens is that, when more and more people pitch that if you have AI and ML platform, you save so many $1 million. The problem with me is that it is not solving my problems, but the CFO is running after me saying that where are those $1 million? So on the lighter note, that's one of the issue. The practical problem is that the amount of data that should come from the SCADA or from the OEM machine, that is very limited, number one. Second problem is that if I want to put additional sensors, then it has to be a system which accepts the IoT data. So basically I have to get those data from outside of the OEM SCADA, because the OEM SCADA does not allow me to take this additional data into their system. So that is one of the challenge. So what we are moving on with is working out a real-time analytics system in the first place, not exactly with the AI and ML, because in last 2 years we have observed that we have been maintaining our systems reasonably well. We don't have so many deviations being thrown up by the system, and that's where I'm just taking this confidence that if for 2 years I do not have the problem, that means I can do away with AI ML and move on real-time analytics. The disadvantage which I see at a personal level on the AI ML is that Mr. Nayak has been talking about the quality of manpower. The manpower is completely relaxed. They are waiting for the system to throw problems out on the alarm systems rather than actually monitoring the parameters. That kind. So instead of AI ML becoming our tool, it is actually becoming our master. That unless AI ML tool tells me there is a problem, my turbine should be fine. There is no problem. So that is one. Second is that none of the tools that we have explored or used so far tells us exactly the probability of their algorithm being true. Because sometimes all the platforms, they work on Vestas machines, SGRE machine, or Tuflon machine, all other machines, right? And all the generators are difficult, but the algorithm of generator temperature sensing is the same all across. So sometimes you tend to get different deviating results, which are not factual. That's number one. The other thing which I would just like to share as a good experience is that we did a LiDAR campaign in one of our wind farms, and we did come across a resolution of around 10 degrees or 12 degrees of error. So when we started deeply analyzing, we found that the encoder of the wind vane itself had 11.25 degrees of resolution principally. So we just changed those wind vanes. I moved to the higher resolution of 0.2 degrees or so. And that itself moved my static of misalignment from 11 or 12 degrees straight away to 3 or 4 degrees of range. So sometimes, deep diving exactly onto the instruments and what is installed and how the control system functions, there are a lot of things that we can do on site. So our focus right now is to develop real-time analytic systems by which we can integrate additional sensors that we are putting across, including the balance of operation system, because nobody is taking substations into their automation at the moment. And going forward, the grid is demanding more and more compliances. They want us to submit disturbance analysis reports within 1 day, 2 day, 24 hours, 48 hours. If we do not have integrated systems, it will be very, very difficult for us to maintain the compliance and the stability.
Right. Thank you. I'll move to Dr. Susie. Dr. Susie, do you have any thoughts that you would like to share with the IPP representatives that are here?
Yes, I have a couple. The first to say that I completely agree with a lot of the points. You can do the most detailed and complex analytics ever, but if you don't know, one, how accurate and how good the analytic is, and two, you can't make a case to make an action based on that, then you've just spent a lot of money and not really got a result. So really, yeah, we need to focus end to end on how we can understand data, make decisions, and then get the action in the end and actually see the return on the investment. So definitely agree with that. I wanted to speak a little bit around temperature trends, just because it came up a couple of times. So what you will see if you just have like a simple threshold is at some point, if the ambient temperature goes up, it's going to cross that threshold and then it's too hot and maybe the turbine shuts down or there's a curtailment. What you can do with analytics is train a small model to say what temperature should it be based on the ambient temperature. So you can get more of an idea, is the component hot because the weather's hot, or is it hot because there's actually a problem? So you can do those kind of analytics, combining multiple data together just to get a bit more insight to what actually is happening.
All right. I think we can take some audience questions now because I can see a lot of those cropping up. And then if time permits, we'll move to some more questions related to this very interesting topic. The first question is from Mr. Bose Sumantra. Maybe Dr. Susie, you can take this question. What challenges still exist with turbine monitoring and diagnostics that ONYX Insight is working on?
Sure. So I mentioned a couple of these already, but most people would agree that the blades are kind of a sort of a slightly unloved component maybe when it comes to traditional condition monitoring. So at ONYX, we're working a lot. We've partnered with a drone company. We also have some solutions near the root of the blade and very actively working in that area too. Another couple of things that have come up that we're also looking into is how can we expand what we're monitoring. So specifically, what should we do around electrical systems? There's certainly gaps in kind of your end-to-end farm production on what monitoring is done. But obviously we have quite a few solutions already, and at ONYX we're very keen to keep developing those out further.
Right. From the same person, there's another question, Dr. Susie, which is how does ONYX Insight calculate downtime due to turbine underperformance?
Oh, sure. Downtime's quite easy to find. You can kind of see it right out the bottom of the power curve. So you just need to look over a certain wind speed. If the power is below a certain threshold, you can be quite confident that it was down in that 10-minute window. So you can use high resolution data as well if you want. But yeah, you can kind of just figure out what your curve is supposed to be, and when it is not producing anything after that kind of cut in wind speed, you can be quite confident that it's down.
Right. This is from an anonymous attendee. He wants to know, or she wants to know, that what will be the per, I think by WTG cost, they mean what will be the what will be the cost of installation of sensors for conditional monitoring? I don't know. Anyone would like to take a shot at this one? What will be the cost of installation of sensors for conditional monitoring?
Yeah, Khushboo, that can be discussed offline, maybe on case-to-case basis, and then requirements. Yeah, once they can, we can get back to them if they can send us an inquiry or.
Yeah, so. Sure. All right. Another question is how wake can be validated reference to pre-estimate based on SCADA data? Anyone would like to take that question? Okay.
Actually, we can validate the data by checking the power curve. Suppose if the windy data is coming in a 24-hour slot, then we can measure whether this turbine is adhering the designed power curve or not, so that we can analyzing the loss, and we can check all the checking parameters. Suppose whether it is due to the converter temperature, whether it is gearbox temperature, whether it is the anemometer issues, warning signs, and we all have to check this depending upon the TML log. Then only action can be taken.
Okay.
Thank you.
I think Mr. Nayak, what the question possibly is that when they do the initial wind resource assessment, they do assume some losses on the wake. Dr. Susie, I remember that I was seeing, if I remember it right from your presentation, is that you also help people with the wind sector management, isn't it? Basically, when you do the wind sector management, basically you are looking at the losses
Wind farm modeling
within a particular sector. So this is where, honestly, for whosoever has asked the question, actually, I am too searching for the answers as an end user, because I want an optimal controller, but I have not come across any product. If you have come across an established product which can help me to guide, that I can reduce my generation on one of the wind turbines so that the wake effect on the turbine which is there behind is getting reduced and the collective generation can increase. I have this concept in my mind, but I am not an expert like Dr. Susie, who is a good expertise in the physical modeling. Possibly we'll have to take some classes from her to understand how we can model these things on the software. So this is something which possibly the person is asking. So we don't have the exact number or how we can cumulatively make a judgment on the losses versus the program using
DNV
the
came
initial
up.
assessment.
DNV came up with a model of wind farm wake optimization, but I'm not very sure whether it is very successful or not. But the concept is beautiful. The concept says that you can optimize wake impact on different machines, and if say machine number 1 is getting more of the wind, we can reduce the we can change the wind direction and optimize the wake impact on that. Plus the question which was there, how can we validate this? So microsighting is done in the initial stage, and then that is run into the WindPro software. So same analysis can be done after installation of the machines, and with 1 year of data, it can be given, and we can have this post-construction yield assessment done on the turbines in WindPro. So it will give us actual wake which is coming up on individual turbines.
Right.
LiDAR installation somewhat overcome this issue, but not 100%. We installed LiDAR in few of the turbines, but we not got 100% expectations to analyze the poor performance, the wake effort like this.
Right.
I think what you are saying is right, sir. One of the practical problems which I see is that, for example, I have my wind farm. My wind farm is not bounded. There are some other people's turbine also in front of me. So I have data only about my turbines. I don't have the data about their turbines, and they will not reduce their generation to increase mine. So all these complexities actually do happen practically on the wind farm. First.
So we can also add this as a challenges for underperforming turbine, because earlier there is a regulation to maintain a 6D and 5D criteria, but now due to scarcity of land and all that, there is a lot of competition and a lot of quantities in wind farms. So they now stuck into 2D, 2.5D, like 3D. We have seen a lot of cases in that part. Okay, so one thing is that. Second is for this wake measurement, what we simply adopt, if wake is there, so the better way to just do the comparison with your met mast means you just take the wind reference from your met mast and to just means plot a power curve which is wake means wake corrected power curve and a density corrected power curve. Okay, so from that power curve you are able to compare your wake affected turbines, and you have seen a factor, means which factor comes of the comparison between both the turbines.
Right. I see a lot of questions for ONYX, actually, Dr. Susie, Mr. Syam. You can see a lot of questions. So if you want to, type out some of the answers, feel free. I'll try to ask as many of these as possible. But since we have about 13 minutes left, I would just take maybe 1 or 2 of these, and you can then probably type out the answers wherever you feel it's possible. The next question is that somebody wants some white papers from ONYX to know about the technology. Someone else was asking about the presentation also, Dr. Susie. So then there's an interesting question from Ms. Anubhuti, Dr. Susie, who wants to know, how does ONYX assign money to the losses? Do you use a fixed energy price per megawatt hour?
Yes, at the moment, but obviously if it was an Indian project, we wouldn't be giving you that in different currency. So yeah, we're flexible and we will research what kind of an average energy price is. A topic that I am really interested in myself is, can we move into power price forecasting and start to do more kind of technical decision support based on when might the power price be higher or lower? That's obviously quite an involved problem, so I wouldn't promise that to anybody today. But yeah, I do think that in future, those kind of capabilities, we will see them.
Right. A question from Mr. Bhanu Prakash. Have you installed the ONYX system in Vestas 3 to 4 megawatt models anywhere? I think by anywhere, he means across the world. 3 to 4 megawatt turbines of Vestas. Have you installed the ONYX system anywhere, he's asking. If you can share that, if you can send that up, please.
Yeah, I think so. I've definitely worked on some SCADA analytics on large Vestas turbines. I'm pretty sure we've probably got Eco CMS as well, but not so much work on that side, so I don't know exactly.
Right. A question from an anonymous attendee again. This is for IPPs, so maybe any one of the panelists can answer this. Do IPPs conduct their own major maintenance like rotor bearing or gearbox replacement after warranty, or they engage OEM for the same? I think Mr. Shah?
So I think what we are doing right now is that we always have a, the contract with either an ISP or the OEM. And whether it is the OEM or the ISP, they actually do it for us. That is how most of the IPPs are behaving as far as I'm aware.
Right. There's a question, Dr. Susie, from Mr. Bhanu Prakash. What is your suggestion to what is the suggestion for OEMs to install ONYX sensors on turbine drivetrain? And do you have sensors to check the pitch bearing vibration data as well?
Yes, I can answer both of those. So first on the OEM topic, we had a recent link up with GE, so we will be factory fitting our Eco CMS unit on their kind of new platforms. So that's something really we're excited about, ONYX, to be able to supply our solution right from the start, as well as giving strong support to operators at the same time. And then, yes, on pitch bearings, we have a hardware advanced sensing solution called EcoPitch. This you can use to instrument your pitch bearings either in kind of a one-off sweep, or you could have it as a permanent installation and track how those change over time. We also have a new one looking more around how the blade attaches. So varying different monitoring solutions around the pitch bearing.
Right. The final question that I can take before we move to your final remarks is, what does ONYX CMS solution, what does ONYX CMS have, in terms of solutions that differentiate it from the other CMS providers?
That is, yeah, a great question. So we have a good breadth, and again, not particularly my area, but we have a couple of offers. So we have the Eco CMS offer, which is priced pretty well and lets you put the accelerometers on. And then we also have the newest, which is something we've just launched called Eco CMS Flex. This one has a big differentiator that you don't need to rip out all of the parts of an existing CMS system that you might have on your drivetrain. You can basically just kind of upgrade the brain of the system. So go and put the flex box in and connect it to the existing sensors. So kind of a big USP for that is that it's kind of a cheaper install, a better way to get better quality data. If you already have a system there, but it's legacy or not supported so much, or you're not happy with the data you're getting out of it.
Right. We move to the final part of the panel discussion, which is what is your sense of how the Indian wind O&M market is shaping up, or what is the way forward for the wind O&M market in India? Very brief remarks to just sum up everything. I'll start with Dr. Susie and then move one by one. Mr. Shah, Mr. Nayak, Mr. Mishra, Mr. Raijandani, and Mr. Miryala.
Okay, cool. So yeah, I have three. Greater instrumentation outside of the drivetrain. The second one, access to the turbine and knowledge of what's going on and reducing tower climbs. And the third, we must have tools that enable efficient workflows. The tools that people use should allow everyone to be efficient and concentrate on the interesting stuff.
Right. Mr. Shah, your thoughts?
Yeah, I think I believe that now we are moving towards the higher PLFs on the wind turbines, and hence they will be equipped with more instruments. There will be more data available on the SCADA, and the decisions will be made using that. The other thing is that I see more and more investors sincerely giving a thought towards self-O&M. So I believe that once they start moving towards self-O&M, the whole approach of the investors will change. They will seek more and more digitalization on the turbines as enablers so that they can take informed decisions. That's the way I think things are going forward.
Right. Mr. Mishra, how is the O&M market shaping up in India?
So first and foremost, the O&M in India is shifting from OEM-based maintenance to ISP and self O&M mode. And once you get into self O&M or ISP modes, you have 100% of data availability. So it will definitely clear out a market for data analytics.
Ms. Mishra, can you hear me? I think your screen froze. Okay, we'll move to Mr. Nayak and then Mr. Mishra can join in later. Mr. Nayak, your thoughts on the way forward for Indian O&M?
Yeah, actually, due to the commercial obligations, the OEM is not able to perform whatever the wind turbines needs. So if the commercial liabilities can be addressed by the IPP, means you can take the self O&M, then the ISP, then you can do the hybrid models, means we can take these means working both for the development of performance, then it could be better. And somewhat whenever it is conditional based, because both have to be commercial obligations. So like this, and some means in some places we are doing the maintenance through OEM, some conditions we are doing through ISP, and some we are adopting the hybrid model. So that is the way forward. So that proper technicals, means oil changings to be done in prior whatever the protocols, and these sensors can be changed. So IGBT can be replaced previously. So these things can be done. And one more thing is grid parameters. If we setting the grids performance better, so that our 50% headache can be addressed. So stability of internal feeders is also a major things in my point of view.
Ms. Mishra, you were saying.
Yes, can you hear me, Khushboo? Yes, yes. Sorry, my internet conked off. So I was saying that the industry in India, especially the OEMs, we are moving away from OEM-based maintenance to either self O&M or ISP-based maintenance. So once you have ISP or self O&M, you will be having 100% of the data available with you. And then you can invest more into data analytics and predictive maintenance. Plus, for OEM, the investment on O&M is more about they are investing from the O&M cost which they are getting, and they compare their cost based on the O&M contracts. But for IPP like us, it's more about the revenue saved. So we can invest into global consultants coming into picture. We can invest into predictive vibration sensors and make our machines more interactive, so that we save on our high wind generation losses. So the industry will shift towards that. Plus, even with the OEMs, the new contracts which will come up, it will be more of energy-based availability rather than time-based availability. So it will also save huge generation, because the market, the tariffs have reduced a lot. So we cannot even think about losing a penny directly, indirectly, because of inefficiencies of O&M contractors. So we have to pull in the plug on time in contract, so that we can gain maximum out of our contracts and out of our assets.
Right. Mr. Raichandani, if you're there, your closing thoughts or your quick summarization of the discussion.
Yep. So I'm in aligned with all these panelists, but the problem is that if we, because we have also experienced to go with ISP and by self-O&M, but the challenges is still same. Okay, if we go with ISP or by self-O&M, so the problem is data availability is always there, because they have their own design, they have their own patented, they have their own confidential controller and all. So the challenges are little bit down, but the problem is still same. So and if you see, the market is evolving much, and the competition is also there in terms of tariff, in terms of turbine models, because now what happens, everyone is just look about more and more gigawatt of capacity, So they now means much worry about to take the 4 megawatt of turbine model instead of 2 megawatt. Okay, so as a IPP, in a high view of IPP, so the challenges are still same. And the thing is that if we can more involve in the OEM, so I think we can make our assets better.
Right. Mr. Syam and Dr. Susie, I'll move to you. Anything that you would like to add, anything that we might have missed during the discussion and that you thought is worth highlighting, please do speak up and let us know. And after that, we'll close the webinar.
Just to finish, I'd like to thank all the panelists and everyone for attending. And just to say, if you still have questions and you'd like to reach out, I'd love to speak analytics and wind turbines. So yeah, do feel free to contact ONYX, and happy to have follow-ups.
Right. Mrs. Sam, anything that you would like to add?
No, nothing from my end. Thanks for all the panelists. Yeah, as we are, I'm based out of India, and you can reach out to me for all the questions if you have anything on the discussions, or yeah, for the further analysis you may need, or you may need support from solution providers like as all mentioned, Kumud and Kanwarjit, Raichandani as mentioned that the wind OEMs are still predominantly taking care of the O&M market, and then ISPs are still not yet matured in India. That's what I see. I mean, we have had an interaction with many of the ISPs in India, but still they are only good for scheduled maintenances and all. But when it comes to the major components, or when it comes to the controllers, or I didn't see any support IPPs are getting from there. But ISPs needs to get in a strong support from solution providers, but I don't think they have an appetite to take the solution providers into consideration. Why? Because their margin or their market is very low. I mean, that's where I see a strong presence, or IPPs needs to go with the solution providers in the market on case-to-case basis, or as a whole. That is where maybe it's going to happen in the Indian wind on a market.
Right.
Thank you.
Thank you.
Mr. Shyam, one request to please share your presentation with all of us. Yeah.
Sure, Rajan.
Thank you.
On that note, we'll bring this webinar to a close. Big thank you to all the speakers for an excellent discussion on this important topic of turbine underperformance. Dr. Susie, Mr. Mishra, Mr. Nayak, Mr. Raichandani, Mr. Shah, and of course, Mr. Miryala. A huge thanks to our sponsor, ONYX Insights. Also, big thanks to our delegates for those insightful questions. And we do hope that everyone found the discussions insightful. And we do hope to see you at our future Renewable Watch events. Thank you so much.